In this video, we're going to talk about verifying solutions to differential equations. Alright, so we previously learned what a differential equation was. It's just any equation that involves the derivative. So sometimes we'll see it with the Leibniz notation, dsdt, the change in s over the change in t. Sometimes we'll see the prime notation. Right here we also have another Leibniz notation, dy dx. Alright, all these represents derivatives and they're in this equation, so they're differential equations. Alright, so go back really on in your algebra career, we talked about solutions to an equation. Are there anything that makes the equal sign true? For instance, in this, the point 1, 1 is a solution because if I put in 1 for x and 1 for y, I get 3, which is equal to 3. So 1, 1 is a solution because it makes the equal sign true. 2, 1 is not a solution because if I plug that in, I get 5, and that's not equal to 3. So that's not a solution. All right, so before we talked about solving equations and all that stuff, you probably just plugged a bunch of stuff in. Is this thing a solution? Is it not a solution? All right, same thing with differential equations. Is this new type of equation you haven't dealt with before? We just want to figure out, is this thing actually an answer? All right, so is x squared, y equals x squared, a solution to this differential equation? All right, we need to know what y prime is, so we're going to take our example, x squared is 2x. And if we plug that in, we get 2x equals 2x. So is this a solution to the differential equation? Yes, it is. So if y prime equals 2x, y equals x squared, that equation is the solution. All right, and here are kind of solutions are always going to be equations. We need our y and our x's related to talk about derivatives. All right, so now consider this equation. This is a second order one. We won't talk about these a lot, but for verifying we can. Y double prime minus 6y prime plus 8y equals 8. Is this a solution? Well, right away we need to know what the derivative and the second derivative are. So to find the derivative, 2 stays, sine turns into cosine. And we remember, because there's 4 x's in the parentheses, to do the chain rule. And I'll multiply those together to get 8 cosine of 4x. And then y double prime, we take the derivative of the derivative. So we get 8. The derivative of cosine is negative sine of 4x. Again, remember to do the chain rule because that 4x we get 4. Negative 32 sine of 4x. So now we have the derivatives. We're going to plug them into our differential equation and just see what happens. So y double prime minus 6 y prime plus 8 y is our original y, 2 sine of 4x. All right, and we try to simplify as much as possible so we can do some multiplications. 6 times 8 is 48. All right, when we combine some like terms, this is going to give us negative 16 sine of 4x minus 48 cosine of 4x. All right. And that doesn't look like anything useful is going to happen. It doesn't look like anything's going to cancel out, so this is not equal to 0. So this is not a solution. All right, we did our derivatives, we put it into our differential equation, and nothing canceled out. We didn't get 0. So here's one for you to try on your own. We have this differential equation, and we want to verify that this is a solution. All right, so go ahead and try that. Oh, there is a typo. This should be a t instead of an x. All right, so go ahead and try that. Pause the video. All right, try this problem on your own, and I'll show you how to do it in 3, 2, 1. All right, this one's straightforward. Just take the derivative of this. 6t squared minus 2t plus 7. All right, that's y prime. Y prime is the same as dy dx. So this is the same. That's equal to that side we want. So this one is a solution. All right, so here's some important points. A solution to a differential equation makes the equal sign true. So when I put in these derivatives and simplify down, I get a true equation. All right, find your derivatives separately and then plug them into the equation to simplify. So especially that second example, we had to find y prime, y double prime. I find those separately and just plug them in and see what happens.